So in the gym activity, what we're going to do is we're going to go down to the gym and we're going to get to the bleachers. So if I can get my pen to work here, I'm going to have a set of bleachers here. Here are my bleachers. And we have one student that stands here with a light bulb, one student that stands here with a light bulb, and one student that stands here with a light bulb. And so here's maybe like the gym floor here. And so we have our stairs going up here. Then we have two students that stand on this side with batteries. And the positive side of the battery is the side with the dimple, and the negative side of the battery is the other side. Now, remember, the key ideas for this are the ideas that we think you should know, and the whole idea is to give you a better idea of what's really going on in the circuits. So once we have those 5 students there, then we would look at this and say, hey, this is technically a parallel circuit, right? So the other students will take and they'll be starting down here on the gym floor, and then they'll be running up the stairs and either coming across here, or coming across here. So we would say that one of the key ideas is that it's out of positive into negative. We also say that the electrons move, which is called current, when there's a difference in voltage. So remember that the voltage is like the pressure that's pushing the electrons through the circuit. We would also look at that and say, well, where is that difference in voltage coming from? So what supplies that difference? And that is really the battery. It's the chemical reaction in the battery that's causing the voltage to happen. Then if the battery is giving the electrons energy, so it's pushing the electrons up the hill, it's kind of an analogy to the potential energy we studied in the fall, then we would say that the appliances, bulbs, resistors, whatever these 3 things are in the circuit over here, that they use energy, causing the electrons to lose energy. And so as the electrons come back out the other side and they come down this side of the bleachers, they're losing that energy to come back to 0 energy at the bottom. We also know one of the things that's interesting that comes about from this is that a majority of the students, either 2 things will happen. Either the students will typically go through this bottom one, most of them. Some of them will go through the middle one, and very few of them will go up to the top one. Or the other thing that happens is, as the student is coming up the side here, they will look at all 3 of these rows and they'll do sort of the grocery line checkout maneuver, like, okay, which row has the least amount of students in it, and that's the one that I'm going to go through. And that really sort of follows the idea that electrons follow the path of least resistance. The electrons follow the path of least resistance. The other thing that we look at then here is to say, okay, this is a parallel circuit. And so in a parallel circuit, then the currents all add up. So remember, if I have 20 students here, then I'm going to split all 20 of them across those 3 different branches. And the voltage is constant. In the other part of the lab, what we would do is we would take and move this light bulb up here, move this light bulb up here, and now we've created a series circuit where we have one continuous flow. They come up the steps, come across, and come back down the side over here. And in that case, we would say that the current is constant or is the same for all of those, and the voltage is what adds up. So that's the first activity that we would do. The second activity is we would do sort of a visualizing activity where you picture yourself as if you are the electron. Now, we don't know what an electron looks like. We have an electron microscope that uses something to interact with the electron to sort of get a sense of where it is, because it's too small for us to use to see with the naked eye. Like, we have to visualize it on the computer. So picture yourself as if you're the electron. You wake up in the morning all charged up. You leave the battery out the positive side or out your front door. Then maybe you go to school, and by the time you leave school, you're like, okay, I'm kind of tired, but it's okay. And then you go to sports. Maybe you're in some sort of athletics or theater or something after school. And by the end of that, you're like, okay, I'm really getting tired now. And then maybe you go to work after that. And so by the end of that, you're just dog tired. You come home, you go in the back door, you lay down and rest again just to charge up and do it all again tomorrow. And that's kind of a one model of looking at what's going on in the circuit. The other model that we look at in class is we would look at topographic maps. So if you've never seen a topographic map, it's the one where you would have, like, here is a map and there's a mountain here. So here's the peak of the mountain. And then all of these concentric circles tell you all the same elevation of the mountain. So it's really steep here because there are a lot of lines all together, but then as you get further and further out, it sort of flattens out. Well, the same thing, if we think of this as water, like this top part's going to be our plus charge. The water is going to flow out of positive into negative down the mountain, and then the water cycle will bring it back up and drop it back up on the top of the mountain again. And so the water cycle, like that, acts like the battery that's putting it back. So there are three different models or ways of looking at what's going on in the circuit to sort of give you at least a visualizing. Now, remember the model, the idea of a model is it's not 100% accurate. It just gives you one way to sort of analogize or think of the things the way it's going. So once you have those ideas, what you want to do is you want to take and memorize these. These are key concepts, and then you're going to take the gym quiz from that activity there.